Humanoid robots are not coming for your home first, they are coming for the work people already feel tired of doing. Boxes, shelves, factory aisles, night shifts, backroom logistics. The quiet places where the economy keeps moving but nobody really wants to look. And that is what makes this story serious. The robot that changes the economy will probably not look like a movie character. It will look plain. It will lift something. Move it, scan it, place it, then continue the task for hours. No drama, no emotion, no complaint, just work. And somewhere inside a warehouse, a manager will ask the question nobody wants to say out loud. How much of this job still needs a human? That is the real humanoid robot story. Not robot butlers, not luxury homes, not some perfect future where a machine folds your clothes and makes coffee. The first wave is going somewhere else. Warehouses, factories, logistics centers, automotive plants, airports, hospitals, places where physical tasks are repetitive, measurable, and expensive. My honest view is this: most people are still watching humanoid robots like gadgets. I think that is the wrong frame. These machines should be judged like early workers, not perfect workers, not human-level workers. Task workers, machines built to take one narrow physical job, then another, then a larger workflow. And once that begins, the conversation changes. Because this is no longer only about robotics, it is about labor, it is about cost. It is about who controls physical work when AI finally leaves the screen. For the last few years, AI has mostly lived behind glass. Chat windows, image tools, video models, coding assistants, useful systems, yes, but still trapped inside phones, laptops, and cloud dashboards. Humanoid robots change the meaning of AI because they give intelligence a body. Once AI has a body, it can touch inventory, carry tools, inspect machines, move supplies, support staff, load parts, assist in real places where people work. And this is the shift many people are underestimating. The next AI race is not only about who has the smartest model, it is about who can connect intelligence to physical action. Because a model that writes text is valuable. A model that can guide a machine through real work is something else entirely. That is why this race matters. Boston Dynamics, Tesla, Figure AI, Agility Robotics, Unitree, Engine AI, Nvidia, Google, Microsoft, Meta, OpenAI-style AI systems. Different companies, different strengths, but the direction is similar. Build the body, train the brain, lower the cost, manage the fleet, own the workflow. That is the stack. And in my opinion, the company that understands the full stack will matter more than the company with the flashiest demo. Let's start with Boston Dynamics. Atlas recently showed a task that looked almost casual at first. The robot lifted a heavy mini fridge, carried it across the lab, rotated with the object, then placed it where a human could use it. On the surface, it looked like a robot delivering a drink, but the drink was not the story. The fridge was not even the story. The real story was whole body control. Atlas had to manage weight, grip, balance, foot placement, torso motion, object movement, and timing, all at once. Humans do this without thinking. A worker picks something up, feels the load, adjusts posture, shifts weight, and keeps moving. For a robot, none of that is natural. Every movement has to be controlled. Every mistake can create instability. Every awkward object changes the problem. This is why the Atlas demo matters. It is not about one fridge. It is about whether a humanoid can begin handling real-world physical complexity. And real work is messy. Boxes are not always centered. Tools are not always placed correctly. Floors are not always clean. People walk through the space. Lighting changes. Carts move. Objects get damaged. A robot that only works in a perfect lab has limited value. A robot that can move through imperfect spaces starts becoming useful. That is the gap Atlas is trying to close. Boston Dynamics has always been strong in motion, balance, recovery, agility, whole body movement. Now the question is whether that movement can turn into labor. Because movement alone is impressive. Work is different. Work has timing, cost, safety, repeatability, maintenance, failure rates. A demo can impress the internet. A deployment has to survive the shift. My take on Atlas is simple. Boston Dynamics is not trying to win the cheapest robot race first. It is showing what a high-end industrial body may need to do. A humanoid that cannot handle weight, posture, and balance is not ready for serious physical work. But a robot that can combine movement and manipulation starts entering a more valuable category. Still, there is a hard truth here. The most advanced body does not automatically become the most adopted product. If the price is too high, if the maintenance is too complex, if the deployment process is slow, businesses may admire it without buying it at scale. That brings us to the second part of the race: endurance. A robot is not useful because it can do one task once. It becomes useful when it can repeat a task safely, consistently, and cheaply enough to justify its place on the floor. This is where Figure AI becomes interesting. Figure is not only selling a robot story, it is selling a work story. Its factory progress with BMW matters because it moves the conversation away from stage demos and toward production environments. A factory does not care about a beautiful clip. It cares about uptime, cycle time, error rate, safety, maintenance, integration, and cost per task. A robot that needs constant human rescue is not a worker. It is another problem for the team. This is why long-duration trials and factory pilots matter. Not because every claim should be accepted without question, not because every robot is ready, but because the market is starting to ask better questions. Can the robot keep working? Can it recover from small errors? Can it work near people? Can it report issues? Can a supervisor manage multiple units? Can the workflow continue when one robot stops? That is the shift from robot demo to robot operation. And operation is where the real money is. One humanoid is interesting. Several humanoids inside a workflow are a pilot. A fleet that can charge, update, report, and resume tasks becomes infrastructure. That word matters. Infrastructure. Because a robot body by itself is not the full product. The product is the system around it. The charging stations, the dashboards, the safety rules, the maintenance process, the training data, the fleet software, the integration with warehouse or factory systems, the human supervisor tools. That system is what businesses will actually depend on. A humanoid with no operating layer is expensive hardware. A humanoid with a full workflow becomes a labor platform, and that phrase should make people pause. A labor platform. Not a toy, not a showcase machine. A managed layer of physical work. For warehouse workers, this has a very real meaning. The first tasks will not be glamorous. They will be repetitive. Moving containers, sorting packages, loading parts, scanning labels, carrying supplies, walking the same path many times in one shift. These are jobs where people get tired, where injuries happen, where turnover can be high, where managers already struggle to hire or retain workers. For one employee, a robot may reduce strain. For another, it may reduce hours. Both can be true at the same time. That is why the human impact is complicated. It is not simple fear. It is not clean optimism. It is pressure. Pressure on workers. Pressure on managers. Pressure on companies that do not want to fall behind. And pressure on the public to understand what automation actually does. It does not always replace a full job on day one. It often removes tasks first. A little walking, a little lifting, a little scanning, a little sorting. Then the job changes around those missing pieces. The worker still has a job, but the job is not the same anymore. This is the quiet version of automation. No dramatic announcement, no single day where everything flips. Just one task removed from a shift. Then another. Then another. Until the role has been redesigned. Now let's talk about Tesla Optimus. This is the most polarizing robot in the race. Some people think it is overhyped. Some believe it could become one of Tesla's most important products. Both sides have reasons. Tesla has made aggressive timelines before. Skepticism is fair. But ignoring Optimus would also be weak analysis. Because Tesla's advantage is not only the robot, it is the machine behind the robot. Factories, batteries, motors, vision systems, manufacturing discipline, supply chains, internal testing environments, and a culture that treats scale as the main event. The key question is not whether Optimus looks better than every other humanoid in a demo. The better question is whether Tesla can build a useful robot at serious volume. That is a different challenge. The best-looking robot may win attention. The scalable robot may win purchase orders. A machine that can be manufactured, repaired, updated, and deployed repeatedly has a different kind of power. And Tesla has one major advantage. It can test Optimus inside its own world. Inside its factories. Inside repetitive manufacturing tasks. Inside environments it controls. Tesla does not need to convince every outside customer on day one. It can prove value internally first. One task, one station, one workflow, then more. If Optimus starts saving time inside Tesla's own operations, the entire story becomes stronger. Because the sales pitch stops being a promise. It becomes an example. That is the part people should watch. Not only the walking footage, not only the hand movement, not only the stage presentation. Watch the factory use case. Watch the task. Watch the reliability. Watch whether humans have to keep stepping in. My bold take is this: Tesla does not need to build the most elegant humanoid to matter. It needs to build the most scalable, useful humanoid. Useful is the important word. Not perfect, useful. A robot does not have to do everything a human can do. It only has to do enough valuable tasks to earn its place. That is where the business case starts. And if Tesla proves that inside manufacturing, competitors will pay attention. Not because they love humanoids. Because no manufacturer wants to carry higher labor costs than a rival if automation becomes practical. This is how pressure spreads. One factory tests. A competitor studies it. A supplier adjusts. A workflow becomes common. Workers feel the shift before the public fully understands it. That is why Optimus matters even with all the skepticism. It connects robotics to manufacturing scale. And scale is where the market gets serious. Now, Agility Robotics is a quieter story. But quiet does not mean weak. Digit is built around logistics work. Moving totes, handling containers, supporting material flow. This may not create the loudest viral moment, but it is exactly where early automation makes sense. The first useful robots will not always look exciting. They will look repetitive. That is not a flaw. That is the point. Businesses measure boring work carefully. How many items moved? How many minutes saved? How many injuries avoided? How many interruptions? How much downtime? A robot does not need personality to be valuable. It needs predictable performance. Digit shows something practical. Humanoid adoption may begin with narrow tasks in structured spaces, not full human replacement. Not general intelligence in every environment, just a clear job in a defined setting. Pick up, move, place, return. Repeat the workflow. If that saves money or reduces strain, companies will test it. If it works, they will expand. This is how robots enter the economy. Not as dramatic symbols, as process improvements. And process improvements can still change lives, because the person doing the old process may not disappear overnight, but the work around that person begins to shift. They may supervise, they may troubleshoot, they may handle exceptions, or they may be asked to do more with a smaller team. The outcome depends on management decisions, labor markets, training, and cost pressure. Technology opens the door. Businesses decide how far to push it. Now comes the part Western robotics companies should take very seriously. China is attacking cost. Unitree, Engine AI, and other Chinese players are pushing humanoids toward lower prices and faster availability. Not every low-cost humanoid is ready for industrial deployment. Some will be limited. Some may be fragile. Some may be more useful for developers than factories. But cost changes behavior. A robot that is too expensive stays in presentations. A cheaper robot gets tested. More testing creates more data. More data improves the ecosystem. And ecosystems are powerful. This is the price ladder I keep thinking about. A $200,000 robot is a boardroom experiment. A $50,000 robot becomes an operations discussion. A $15,000 robot becomes a developer platform. A $5,000 robot changes who gets to participate. Cheap does not mean better. Cheap can break. Cheap can lack safety. Cheap can be limited. But cheap spreads. And spread matters. More people test. More developers build. More labs experiment. More students learn. More companies try small pilots. That is how a category grows. China may not win by building the most graceful humanoid first. It may win by making humanoids common. That is a different form of power. Western companies may lead in high-end performance, software, safety, or enterprise trust. Chinese companies may compress the cost curve. If that happens, adoption could arrive faster than many people expect. Not because every robot is amazing, because enough robots become accessible. And once hardware becomes accessible, software innovation accelerates. People start building around it. Training improves. Use cases appear. Small companies enter. The category stops feeling distant. That is how markets change, not all at once. Then, slowly, everywhere. Now let's zoom out to the hidden player. Nvidia. Nvidia does not need to build the humanoid that walks into the factory. It can still power the system that teaches thousands of robots how to work. Robots need compute. They need simulation. They need vision processing. They need training environments. They need edge AI. They need digital twins. They need models that connect perception to action. The public watches the robot body. The industry watches the training stack. That difference matters. A chatbot can make a mistake and rewrite a sentence. A robot makes a mistake and may drop something. Hit something. Block a path. Damage inventory. Or create a safety issue. Physical AI has consequences. So robots need a different kind of training. You do not want a humanoid learning every mistake inside a real warehouse. You want most failures to happen in simulation first. Different floors, different lighting, different object weights, different shelf positions, different human interruptions, different routes, different edge cases. Then, the best behaviors can transfer into the real machine. The robot people see walking on a factory floor may have learned most of its lessons in a virtual environment. That is why simulation is not a side detail. It is the training ground. And this is where Nvidia becomes dangerous. Robot companies can compete with each other while still depending on similar compute layers. Boston Dynamics needs training tools. Figure needs robot learning systems. Tesla needs AI infrastructure. Startups need simulation. Factories need digital twins. Developers need platforms. The body gets attention. The platform may capture value. A serious investor does not only ask which robot looks better, they ask which layer becomes unavoidable. Hardware can become cheaper. Motors can improve. Sensors can standardize. Bodies can become more common. But the software, simulation, cloud, fleet management, and data layer may become the real control point. This is why humanoid robots are not only a robotics story, they are a big tech story. Google, Microsoft, Meta, OpenAI-style AI companies, and cloud providers may not all build robot bodies. They could still fight for the robot brain. Language models understand instructions. Vision systems understand objects. Planning models break tasks into steps. Cloud platforms manage fleets. Enterprise software connects workflows. Now imagine a supervisor saying, "Take those boxes to aisle 5. Scan the labels. Separate damaged items. Do not move fragile packages without confirmation. Report anything missing." That task is not just walking. It requires language, vision, memory, planning, safety, exception handling, and communication. This is where AI models become physical tools. The robot body may become the device. The operating layer may become the business. Think about smartphones. The phone mattered, but the ecosystem mattered more. Apps, services, cloud, payments, developers, user data, distribution. A similar pattern could appear in humanoids. The robot body will get the headlines. The platform may get the profits. Someone will control updates. Someone will control fleet software. Someone will control training data. Someone will control safety systems. Someone will control business integration. Someone will own the default interface between AI and physical work. That is the real platform war. And it is much bigger than one robot walking on stage. Now pause for a second and think about your own work. Which part of your day is repetitive? Which part is physical? Which part follows clear steps? Which part can be measured? Which part is predictable enough that a machine could practice it? That is the part robotics companies will study first. Not your full job title, not your personality, not your experience. The task. This is the uncomfortable part. A robot does not need to replace you to affect you. It only needs to take the part your employer can measure. For some workers, that will be helpful. Less lifting, less strain, fewer injuries, less walking. For others, it may mean fewer hours, less overtime, smaller teams, more monitoring, more pressure to move into different work. This is why the job debate is too simple. One side says robots will take everything. The other side says robots will only help. Reality is harder. Some tasks will disappear. Some jobs will change. Some workers will supervise machines. Some companies will reduce hiring. Some teams will become more productive. Some people will be pushed into retraining before they are ready. The human impact is not one clean story. It is uneven. A warehouse worker may feel it one way. A factory manager may see it differently. A hospital administrator may focus on staffing shortages. A logistics company may focus on cost. A worker may focus on security. Same technology, different consequences. This is why I do not like shallow robot hype. It misses the people. It misses the uncertainty. It misses the operational friction. A clean demo is not a 6-month deployment. A smooth walk is not factory reliability. A robot lifting one object is not full automation. Hands break. Motors wear down. Batteries degrade. Sensors drift. Software freezes. Networks fail. Dust gets everywhere. People behave unpredictably. Warehouses are not polite environments. Factories are not demo stages. This is where robotics becomes hard. The most important number may not be walking speed. It may be failure rate. A slower robot that works every day is more valuable than a faster robot that breaks every shift. Businesses care about uptime, safety, support, maintenance, total cost, insurance, downtime, training, integration. This is where serious robot companies will separate from demo companies. The winners will survive boring reality. Not just the stage, not just the lab, the floor. That floor is where claims become numbers, tasks per hour, failures per week, maintenance cost, safety incidents, human interventions, battery cycles, replacement parts, workflow delays. These are not exciting words, but they decide adoption. My prediction is this. In 2026, we see more pilots, more demos, and more early deployments. In 2027, the serious companies start proving fleet behavior, not only single robot performance. By 2028, the question may shift from, can humanoids work? To, which companies can afford not to test them? By 2030, I think humanoids become normal in selected industrial environments. Not everywhere, not every job, not every business, but enough places that people stop treating them as strange. And once a technology stops feeling strange, adoption gets easier. That is the psychological shift. First, people laugh. Then they doubt. Then they test. Then they compare costs. Then they ask why competitors are moving faster. By that point, the debate has already changed. So who is leading? It depends on the layer. Boston Dynamics has movement credibility. Figure has strong factory work momentum. Tesla has the scale story. Agility has practical logistics focus. Unitree and Engine AI have cost pressure. Nvidia has the hidden infrastructure layer. Big tech wants the robot brain. This is not one race. It is several races happening at once. Movement, manipulation, battery life, hands, manufacturing, simulation, AI models, fleet management, safety, enterprise integration. The public asks, which robot is best? I think the better question is, which layer becomes the business? Because the most visible company is not always the most profitable one. The robot walking on screen may not be the final winner. The company powering training, software, deployment, and data may capture more value. This is the part that makes humanoid robots different from old machines. They are not just hardware products. They are learning systems. Each deployment can generate feedback. Each failure can improve future behavior. Each workflow can teach the fleet. Each customer can reveal a new use case. If that loop works, improvement can compound. Better robots create more deployments. More deployments create more data. More data creates better models. Better models make robots more useful. More usefulness drives adoption. That loop is what every serious company wants. But the loop also creates power concentration. If one platform controls the learning layer for thousands of robots, it may become extremely difficult to compete with. That is why I keep coming back to the same point. This is not only about machines walking on two legs, it is about who owns the operating system for physical AI. Now, for business leaders, the smart move is not panic, and it is not blind buying. The smart move is task mapping. Look inside the operation. Which tasks are repetitive? Which tasks cause injuries? Which tasks are hard to hire for? Which tasks happen in structured spaces? Which tasks can be measured clearly? Which workflows already depend on people walking, lifting, scanning, or moving objects? Those are the first places to study. The companies that learn early may gain an advantage, not because they buy the first robot, because they understand the workflow before everyone else. When robots become cheaper, the real advantage may be knowing exactly where to use them. For workers, the question is different. Do not only ask, is my job safe? Ask, which parts of my work are easiest to automate? Then ask, what human skill sits above those tasks? Judgment, coordination, customer interaction, repair, safety oversight, problem solving, training, exception handling. Those skills become more valuable when routine physical work becomes automated. But this transition will not be fair by default. People need time, training, clear communication, and honest policy. Without that, robots may increase productivity while leaving many workers confused about where they fit. That is the part nobody should ignore. Technology can create efficiency. It does not automatically create fairness. So here is my full view. Humanoid robots are overhyped in the short term and underestimated in the long term. Overhyped because many clips make them look more ready than they are. Underestimated because people keep judging each update alone. Atlas carrying a heavy object. Figure working toward factory tasks. Optimus aiming for scale. Agility focusing on logistics. China pushing costs down. Nvidia building the training layer. Big tech chasing the brain. Individually, each story is interesting. Together, they point to something much larger. AI is moving from words to work, from chat boxes to factory floors, from software output to physical action, from digital assistants to machines that can operate in human spaces. This does not mean robots replace everyone tomorrow. That is not serious analysis. The more realistic path is slower and more powerful. First, robots take narrow tasks. Then, workflows adjust. Then, companies compare results. Then, costs fall. Then, pilots spread. Then, the public notices the change after it has already started. The future may not arrive as one robot replacing one person. It may arrive as one task disappearing from a shift. Then another, until the job itself looks different. So before asking whether a humanoid robot will take your job, ask a sharper question. Which part of my job is already repetitive enough for a machine to learn? Which part is physical enough? Which part is measurable enough? Which part is boring enough that a company would gladly automate it? That question is uncomfortable, but it is more honest. And for businesses, the question is just as direct. Which task should we test first? Which workflow has the clearest value? Which vendor can support us after the demo? Which system can survive the real floor? Which platform improves over time? The next 12 to 18 months will be important because they will separate stories from operations. Some companies will prove useful workflows. Some will stay stuck in impressive clips. Some will discover the robot is not ready. Some will learn early and gain an edge. That is how new technology usually enters the economy. Not through one clean moment, through uneven tests, real failures, small wins, cost pressure, and competitive fear. The humanoid robot race is not just about machines, it is about who adapts first. Workers, companies, robotics startups, big tech, governments, supply chains. Everyone has a stake. Because once AI can act in the physical world, the boundary between software and labor starts to blur. And that is why this story deserves more attention than a viral clip. A robot carrying a fridge may look simple. A robot sorting packages may look boring. A robot walking through a factory may look slow. But these are early signals. Signals that AI is learning to move. Signals that companies are preparing for robot labor. Signals that the next platform war may not live inside your phone. It may walk into the places where real work happens. So here is my question for you. Which industry gets hit first? Warehouses, factories, hospitals, airports, retail, elder care. And be honest, if a humanoid robot could do one repetitive part of your work tomorrow, would you call it help or would you call it a warning? Drop your answer in the comments. This is AI Controller. AI News. Humanoid robots. Big tech updates. The next AI war will not only be written in code, it will be built in metal, trained in simulation, managed through software, and sent into the real world.